Hey, everybody. It's me. Long time no see. All right. Hi, Kate. I just saw you popped on. So we have a good group here already. So I think making popcorn, that actually sounds good. Let's get started. We've got homework 2. We have 20 questions. It should look like this with fraction bars at the top. So that's the one that we are going to be working on. And we will get started with number 1. Bertha plans to trim 3 collars on her daughter's dresses. Do you know what collars are? They're things that kind of like either flip around or like on men's dress shirts. Sometimes they're on dresses. They can be like lace or something pretty. Anyway, those go on dresses, and Bertha needs 1/4 yard of lace for one collar, 1/6 yard of lace for the second collar, and 5/12 yard of lace for the third collar. Each strip below represents 1 yard of lace. Which strip is shaded to represent the total amount of lace that Bertha needs to trim 3 collars? Now, putting the awkward name Bertha aside and the fact that she's cutting lace for dresses that probably were made in the 1800s, what kind of math are we doing here if we're looking for the total amount of lace Bertha needs to trim the 3 collars? You guys can pop in with some chat and answers and idea. We may have to do a conversion to find we're in the right place. We have 1/4 yards of lace for one collar. She needs another 1/6 yard of lace. And then another lace, she'll need 5/12 of a yard of lace. So what do you think we need to do in order to get the total of these 3 amounts? Hi, Karina, I see you. Your backpack is a forest. Yes, we can actually add all 3 fractions, but we cannot, knowing that we have 4ths, 6ths, and 12ths, we can't add them like they are, so we need common denominators. So it's time to change them so that they do have a least common denominator all the same. So what multiples do 4, 6, and 12 all have in common? Well, the lowest one is 12. So I'm going to rewrite 3 new fractions, all with 12 as my denominator. And the cool thing about this one is that this is still 12ths. So this one will not have to change. However, hi, Kirby, I see you. I'm so sorry you're sick. So how can we convert 4ths into 12ths? Well, we make 3 times as many pieces. So we have a times 3 relationship, and whatever we do to the bottom, we have to do to the top. We have to make 3 times as many pieces on top as well. So if 4 times 3 is 12, 1 times 3 is 3. Adam, we stay on topic here, okay? I see your llamas. All right. And how do we get from 6 to 12ths? Well, we make 2 times as many pieces, or a times 2 relationship. So 6 times 2 is 12, and therefore we have to do the same thing to the top. 1 times 2 is 2. And now that we have all of the same denominators, we are free to add all of our numerators. So how many 12ths in all do we have? 3 plus 2 plus 5. That should be 10 12ths. Your job is to pick the strip that is the one where I learned math. Yes, you like my friend's shirt. We're picking the one that has 10 out of 12 strips or pieces shaded. All right, Aiden, welcome. And Maddie made it, yay. Did you decide not to go to dance? All right, good job, guys. All right, number 2, Cassandra bought new tennis balls. And of the 6 balls she bought, 1/3 of them are hot pink. So she has 6 tennis balls. I'm going to draw the diagram like it is. Of course, it looks much nicer on the paper. And 1/3 of these tennis balls are hot pink. I know. And Becca's flashing her answer behind the camera here. So if I know if I, using this model, 3 equal groups, and I'm going to pick how many tennis balls are in one of those equal groups. So if I split the tennis balls like this, I have 1/3 here, 1/3 here, 1/3 here for a total of 3 separate groups. I need to find out how many tennis balls are in 2. I'm sorry, just gave the answer. 1/3 of those 6 tennis balls. And I'm going to shade in one of those thirds. And how many tennis balls is that? Yes, Becca, you were right. Great job, guys. See, nothing changes after school. I still mess up just like I do in class, right? So, Julia, we're talking about, we're not asking what fraction of the tennis balls is 1/3. We know the fraction. We're looking for how many actual tennis balls were in 1/3 of those 6, that set of 6 tennis balls. All right, number 3. Number 3, I'm hoping we spent enough time on these because I have 2 whole circles, and they're not. They are actually split up. I'm not going to do this right. I know it. Can you pretend that they're right? And how many pieces are they each split up into? And I'm looking, so Kip drew a much better model than me, but we're looking for which division model or division expression does his model represent? Well, if we look, we're given 2 whole circles, and those 2 whole circles are divided somehow. Well, there's 1, 2, 3, 4, 5, 6 pieces, or each piece is worth 1/6. One sixth here, 1/6 here, 1/6 here, 1/6 here. So if those 2 whole circles were divided into 6ths, what's our equation? That's why we're here, Callie, right? We're gonna fix it right away. No big deal. It is not A. We do have 2 whole circles, but we're not dividing each circle into 12 equal parts or 12ths. We're taking 2 whole circles and dividing each circle into 6ths. Not C, because C says we're starting with 12 and we're dividing it by 6. Do we have 12 whole circles here? Nope. We have 2 whole circles, so it's got to be 2 divided by something, right? 2 divided by what? Julia, you would be right. We are dividing 2 into sixths, which is the same as 2 divided by 1/6. And when we take 2 and divide them into sixths, how many pieces do we have? These could be pies. Would it had been better if I went with food like usual? So 2 whole pizzas divided into sixths. How many pieces of pizza do we? 4, 5, 6, 7, 8, 9, 10, 11, 12. Extra cool points, write out the equation with the quotient. Becca's hungry. Pi. Yes, pi would have worked too. All right, let's move on to number 4. Ricardo had 2 1/3 pounds of cornmeal, and he used 1 3/4 pounds to make corn tortillas. How much cornmeal does Ricardo have left? So what does that mean? What kind of math are we going to be doing? And yes, if we do get off topic and we're not talking math and contributing positively to the conversation, I will either turn off the chat or have to block some people. So let's keep that in mind. All right, so if Ricardo started with 2 1/3 pounds of cornmeal, he used 1 3/4 pounds to make corn tortillas. How are we going to figure out how much he has left? What kind of math is that? Is that addition, subtraction, multiplication, or division? All right, Maddie, you've got it with subtraction. We are going to set up our subtraction problem. 2 minus 1 3/4. Hopefully I got those numbers right. Somebody want to check on me? All right. So I actually became a fan. I remember I told you I loved working with improper fractions the most. When we did enough of these mixed number subtraction problems, I actually became a fan of doing it your way. So I know I can't subtract. I could take my whole numbers and subtract them, but I can't take my fraction pieces and subtract them because they have different denominators. So I'm going to rewrite my mixed numbers. 2 and something twelfths minus 1 and something twelfths, because 12 is a good low common denominator for both 3 and 4. How do we get from thirds to twelfths? By a times 4, which means we have to do the same thing to the top. And 4 is our new numerator. 4 fourths, become twelfths by making 3 times as many pieces. Therefore, I have to make 3 times as many pieces on top, and 3 times 3 makes 9 pieces. So when I go to do 2 minus 1, and I have common denominators, so I'm free to subtract. 2 minus 1 is 1. 4 minus 9. What do we do here? Hi, Graydon. Glad you could join us. We can't do that because if I'm taking away 9, I only have 4. I can't do that. So I actually need to decompose this. If I take away 1 whole, I can add it in its twelfths version to the 4 twelfths that I already have. So 2 is the same thing as 1 12 twelfths. So I'll just add that to the 4 twelfths I already have. And then I'll subtract 1 9 twelfths. So 1 and 12/12 plus 4/12 is 1 and 16/12 minus 1 and 9/12. And now subtract the whole numbers. 1 minus 1 is 0. 16 minus 9 should be 7. Great thinking, Maddie. And 12ths. So that's how many pounds of cornmeal he should have left over. Llama Llama Logan, is that Logan C or Logan L? Great job. Okay, if I erase it? It's not. Okay. Okay. Moving along. Number 5, Rachel bought 4 bags of potting soil to fill planters on her patio. She used 1/3 of a bag to fill each planter. Great job, Callie. Great job, Kate. Yes, or Adam actually has the right letter, but same difference, right? If each planter is the same size, what is the number of planters she can fill with the bags of soil? So I'm having a hard time figuring out what's going on here. So I think I'm going to draw a picture. I'm going to use a rectangle for my bag of soil because she has actually 4 bags. So here is 1 bag. Here's 2 bags, 3 bags, 4 bags. And she uses 1/3 of a bag to fill each planter. A planter is just the pot that the flour and dirt go in. So if this is a bag and I use 1/3 of the bag, I can split this into thirds for a total of 3/3 to equal the 1 bag. I'll just make that note right here just to show you why I broke it up into thirds. And I get how many planters out of 1 bag? I get 3 out of this one. So how many am I going to get out of 2? How many am I going to get out of 3? And how many are we going to get out of 4? Because remember, each third represents a pot or a planter that she can fill with this much soil. Try again, Aiden. You just kept adding. No, we're not adding. We're saying that this 1/3 of a bag represents the amount that can fill 1 planter. So this is for 1 planter. This is for 1 planter. This is for 1 planter. So if I can get 3 planters out of 1 bag of soil, how many planters full can I get out of 4 bags? Well, I can get 3 out of 1. I can get another 3 or 6 out of 2. I can get another 3 another 3 or 9 out of 3 bags. Yes, Julia, 3 times 4. So if I take 4 and I divide it into thirds, that's the same thing as saying 4 times 3. So then you can do the multiplication. And these are the notes I wrote, how I organized my information. I gathered that she had 4 bags, 1/3 bag each planter, 3 planters per bag. So I ended up, it's supposed to be from our division of unit fractions unit or module from module 9, but really, I don't know when we ever say we divide it in thirds, but we just know we get 3 planters out of the 4 each 4 bags to equal 12 planters. So I hope that's okay. And we can move on. If there's any questions, just let me know. Jump in. Hi, Celine. You made it. All right, number 6. Which pair of numbers is a factor pair of 72? We're going back to prime, composite, factors, and multiples. If you remember what a factor is, it's not 13, Weston. It's okay. 4 times 3 is not 13. All right, so a factor is a number that multiplies by another number to get a product. So something like 2 times 3 equals 6. 2 and 3 is the factor pair because factor times factor equals the product. Don't forget to take some good notes, okay? All right, so we're looking for a factor pair that equals 72. And I started making a factor table, like one or a T-chart, like 1, 72, 2, whatever, the other 36. But then I realized, well, there's only 4 choices. Why don't I just try 4? Try the 4 choices instead of making a long list of factors of 72. So I tried 4 times 24. You need to try 3 times 28. You need to try 5 times 13. And you need to try 6 times 12. Four times 24 is not 72. So if we set up a 2, we're multiplying a single digit by a 2 digit. Read it again? Sure. Which pair of numbers is a factor pair of 72? I'm going to try 24 times 4. And I start over here. 4 times 4 is 16. Carry my 1. 4 times 2 is 8. Plus 1. And that's 96. So F does not work. 28, 3 and 28, or 28 times 3. 3 times 8 is 24, and carry the 2. 3 times 2 is 6. Plus 2 more is 8. That's 84. So G doesn't work. 13 times 5. 5 times 3 is 15. 5 times 1 is 5, plus 1 is 6. So that one does not work either. And it is, and I kind of felt silly for go, because I really did. I worked out every single one. I divided 70. Why did I do that? I try to make things so hard sometimes. Anyway, if you do 12 times 6, you do get 72. If you know your 12 facts, you know that 12 times 6 is 72. Or if you do standard algorithm, you do 6 times 2 is 12. Carry your 1. 6 times 1 is 6, plus 7 is plus 1 is 7, which is 72. I know. I think I gave her a good look too. I didn't have to say it out loud. All right, number 7. A school flag designer needs to find the perimeter of the piece of fabric represented below. What's the shape of that piece of fabric represented below? It is our good old friend, the rectangle. We're looking at 6 yards here. And we're looking at 4 yards here. So 1 is going to be the length. We can call this the length. We can call this the width. And we need to figure out which equation can he use to find the perimeter. So we have to remember, what do they want when they're asking for perimeter? We're looking for the total distance around the shape. So I have to add all of the sides. And what do we know? If we did actually 6 times 4, we're not finding area perimeter. What are we finding when we multiply the length and the width? Callie, you would be right. You need to add all of the sides. We need to find the total distance around. Aiden, enough. All right, so I only have this width or this length and this width. How am I going to know this and this? If I'm going to add up all the sides, how do you know to add 6 2 times and 4 2 times? I think you guys are using your knowledge about rectangles to know that the opposite sides are congruent. So if this side is 6 yards, the opposite side is also 6 yards. And if this side is 4 yards, then its opposite side is also 4 yards. So when you add up all the sides, you should get an equation that adds 6 plus 4 plus 6 plus 4. Adding each side up exactly. All right, number 8, you should be pros now. What do you think? A graphing question, and I am going to actually try and use Miss Pettyjohn's handy dandy chart. Do you see her beautiful chart up here? Let's see. All right. It says the graph represents the relationship between the number of weeks and the number of softball games, G, that a team played. So instead of X and Y, we're talking about W and G. Which number pair extends the pattern shown on the graph? Well, I know that I have, all right, I have 1 and 1. I have 2 and 6. Whoa, that's not 1 and 1. That's 1 and 3, isn't it? Because it's halfway between 0 and 6. So I have 2 and 6. So this graph is going to look a little different than the one on your paper. 3 and 9. And 4 and 12. Okay, so I need to draw a straight line to connect all these dots. And then I'm going to see what other point it goes through. Does it go through 5, 10? Well, we go to 5 and we go to 10. Nope, there's no point there. Go to 6 and 15. Nope, no point there. 15 and 5, definitely not. So it looks like we're good. Let's just check 5 and 15. 5, 15. Yep, there's the line crosses it at that point right there. Aiden, I do make myself available for questions at the end, but you're also welcome to ask questions at any time as long as they are related to the homework. And nobody ask me what's for dinner.
What's for dinner?
Unicorn, Karina, what's your question? I'm going to keep looking at the chat for your question, okay? But I'm going to move on to number 9. And number 9 actually models today's lesson that we, not very funny, Adam, actually is over the lesson that we learned today. There's a pattern in the graph below, and I came away from it, but we're going to use it again. So it's asking which rule describes the pattern. Actually, we don't need that because it gives us all the points, and what I can do to determine the rule is to make a table out of these points. So if I make a table, an X and Y table, or in this case, X is A. Remember, we always do X, Y, but in this case, A, the input is X, and B is your Y. So our first point looks to be at 1, 6. The next one is at, if you go over 2 and up to 7, you go over, is that my phone? My phone broke several times today. We go over 3 and up to 8. What looks to be happening? What kind of rule or process is happening when we go from A or X to B or Y? What's happening from 1 to get 6 to come out? 2 goes in and 7 comes out. So what's happening right here? What's our process rule? We're actually on 9, sweetie. Let's see. If we go to go over 4, we should end up at 9. I think I found a pattern. And 5, 10. So what rule is happening? Hey, Abraham, glad you could join us. All right, if you notice, 5 to 1, I get 6. 2, 7. 3 plus 5 equals 8. 4 plus 5 equals 9. And 5 plus 5 equals 10. So my rule is plus 5. But what is getting added to 5? We're taking A and adding 5 to get or equal. Oops, it's not high enough. Sorry. We're taking A, adding 5 to get our B. So it's not written exactly like that. See if you can find out which equation matches the one we just wrote here. Which equation is the same as A plus 5 equals B? Eight, we already talked about. When the video is over, you can rewind it and go through it again if you want. All right, number 10. Casey bought 140 beads to make jewelry to sell at a craft fair. On Saturday, she used 3 packets of 14 beads and 4 packets of 12 beads. Which expression, it's one of those, which expression represents the number of beads she had left after Saturday? So if we're looking to find out how many beads are left over, then subtraction's got to be involved, right? You're going to have to go back and watch the video, honey. I don't give straight up answers on the videos. We work them out and then you kind of come to your own conclusion. Hopefully to the point where it's easy enough for you to pick it out, but you might just have to redo that number on your own. All right, so I know that Casey starts with 140 beads on Saturday, and we're gonna end up subtracting some beads that she uses, right? She starts with it, we're gonna subtract the amount that she used. What happens? She uses 14 beads. I'm sorry, she used 3 packets of 14 beads each. So 3 packets of, see, not just for fractions, 3 packets of 14 beads each, and, get it, and 4 packs of 12 beads each. Now, thank goodness, nobody's asking us to actually solve this, but we do need to put some grouping symbols to help us before we can subtract anything from 140. We kind of have to figure out how many beads this is first, how many this is, and then the total of these two. So I'm going to do this first. I'm going to do this second. And then I'm going to do all of it and subtract it from 140. What are you looking for? Yeah, it's okay. I don't know what happened to it. Is it in our file? Oh, I saw Margie had a copy. I saw Miss Eslick had a copy of it before. It's okay, but yeah, I was thinking of bringing in the real thing. Just for fun tomorrow if they finish all their work. Sorry. No worries. Okay, so I hope you can figure out which expression looks most like that. Actually, I was wondering, does anybody see if 2 answers work here? It can't be H because it's asking you to do 3 plus 4 and 14 plus 12, and that does not work. I mean, to me, J is the same, because if you worked it out in the proper order, the GEMDAS rules that we learned, I think J does work if you follow the order. So if you do, so J looks like this, 140. This is what the answer key says. So answer key says F. But if we do J, 140 minus 3 times 14 plus 4 times 12. And usually I can see why they don't like this answer as a correct one, because the brackets are usually used after a parentheses. They usually go in this certain order, where the parentheses are the innermost and the brackets are the second most outermost. And then we use braces for the third outermost. So this technically doesn't look right, but if you do the innermost groupings first, you still get 140 minus 3 times 14 plus 48. Well, inside this grouping, you still have to do 3 times 14, which is 42, plus 48, which is what you would get here, and you would still add both together and subtract from 140. Hi, Carter. Glad you could be here. All right. So anyway, technically the answer is F. This is the one time I will give you a straight up answer, because it technically could be 2 of them. The official correct answer is F. The second correct answer that I will take credit for is J. All right, so number 11 is one of my favorites. not just because I like order of operations, but because if I can see through all of the muck that they're trying to throw at us, you'll see that I actually crossed out most of the question. Can you guys read the problem and tell us why I may have just crossed all that out? It says Nigel bought a bag that contained 14 oranges. He put 3 of the oranges in a fruit basket on the dining table. He puts 2 times as many oranges in the refrigerator as he put in the basket on the table. He used the rest of the oranges to make orange juice. The expression is this whole situation. Based on the expression, how many oranges did Nigel use to make orange juice? That just means this information is all well and good, but what all do we just really need? We just need that expression. If we solve or simplify this expression, we should get our answer. And this little dot, I'm sorry, this was written a few years ago by someone else, and we haven't talked about this. I don't think you'll see this on any major test in our class or STAR or anything, but this technically means multiplication. I know we have the X for multiplication, we have a dot for multiplication, we have it mushed up against other letters and parentheses for multiplication. I do not know why we have so many things for multiplication. Anyway, that's what it is. And you'll see that a lot more. You'll see this a lot more in 6th grade too. So we do our groupings first. However, we have addition and multiplication within our grouping. So we're going to do our multiplication first because that always comes before any addition or subtraction. So we're going to work on making some pizza. 14 minus 3 plus, what is 2 times 3? 6. Okay, working on our pizza, solving another step. 14 minus, what is 3 plus 6? 14 minus 9. And when you finish off your pizza slice, you should have a solution. 14 minus 9 equals, it's not 6. I think it's a typo. Great job, you guys. All right, we're more than halfway done. How are you guys doing? You hanging in there? Okay, number 12. The table below represents the perimeter and area of different squares, which could be the next 2 rows in the table. Okay, so I'm going to try to recreate this. 1, 2, 3, 4. 4, 8, 12, 16. And 1, 4, 9, 16. 1, 4, 9, 16. Okay, so this is going up by ones. I'm going to look for a pattern. I know the table is continuing with 5 and 6, but that's in all 4 choices, so that doesn't really help me out. All right, 4, 8, 12, 16. We're adding 4. So 16 plus 4 would be 20. So now we can rule out F and G because those tables start with 25 in the middle. So we're going to cross out F and G. It's either going to be H or J. Well, which one adds 4 after the 20? It's blurry. Is my end blurry or is your computer going in and out? Weston, you would be correct. Julia, absolutely. And what's cool is I didn't even have to go to the third one to check. All right, number 13. Oh, fun. This may take me a minute. I'm going to try to redraw this thing. I think I'll have to. Okay, we have a Venn diagram of regular polygons. Do you guys remember what we mean by regular polygons? Well, if a polygon is regular, that means all sides are going to be congruent. So if a triangle is regular, all three sides are going to be congruent. So we have regular polygons where all of the sides are congruent. And in this circle, we have the regular polygons with congruent angles, which means all of the angles are congruent. And we have the ones with just congruent sides. Not exactly congruent angles. So you could say congruent angles and non-congruent angles if you wanted to. So in the middle here, we have a quadrilateral with all four congruent sides and all four congruent angles. And we're looking for what figure belongs in this section of the Venn diagram labeled regular polygons. Right here. So we're looking at A, and we're looking for something that has to have all four sides congruent or equivalent, and all of the angles must also be congruent. So if you remember, if we have one tick mark for each side, that means those sides are congruent. This goes back to our symbols for congruency. The equal shape is got to be congruent. Yes, Karina. However, look at C. It looks like it has a bunch of those tick marks, but if you look, it has a set of one tick mark on the top and the bottom, but on the left and the right side, they're a little bit longer, which means all four sides are not congruent. Brandon, you would be right. And Karina, yes, you've got it. All right. Well, which figure in number 14 appears, this is where you get to guess, it appears to have two acute angles. Oh, they're so cute. And two obtuse angles. I can do that because it's after hours, right? All right, F. What do you notice about the angles in F? If you look at F, you should notice that they all appear. Hopefully you recognize those as right angles, so it cannot be F. H looks to have two right angles at the bottom, and all of the other angles are obtuse, but that's 3 obtuse and no acute, so that does not fit our criteria. And J looks to have, like it has all 4 angles are right angles. So just make sure G has 2 little acute angles and 2 fat obtuse angles. I'm not doing that in class. Don't anybody tell I just did that. All right, number 15. 5 more, we're done. Yay! All right, Victor drew a figure that appeared to have 3 obtuse angles. Which figure could be the figure that Victor drew? So we're looking for the object that has 3 obtuse angles. A looks like it has some obtuse angles. Obtuse here and obtuse here, but these two look to be acute. So It doesn't have 3. C looks like it has 1 right angle and 2 acute angles, and D looks like it has all acute angles. So your job is to make sure letter B has 3. Oh, you're very gross. You what? I know I'm traumatizing them. Sorry if I'm traumatizing anyone. Yeah. Moving on to number 16. A volume question. A model of a rectangular prism is made of 1-inch cubes and it's shown below. What is the volume of the rectangular prism? All right, I'm not going to draw this. I'm going to just put it right up to the screen. You ready? All right, volume equals length times width times height. 3 dimensions for volume. So we've got 1, 2, 3, 4, 5, 6 for our length. So volume is going to be 6 units times 1, 2, 3 for its width. And how high is this prism? It is 2 units high. So volume is going to be the same as 6 times 3 times 2 cubic units. I will let you do, sorry, I know Maureen got in there, sorry. 6 times 3 times 2 in cubic units is the volume of this rectangular prism. And number 17, the base of a raised herb garden bed is 6 by 4 feet. The height of the garden bed is 2 feet. How many cubic feet of soil are needed to fill the garden bed? Does this sound like a... Okay, a lot of you are answering 16, 18, 15. Were you talking about number 17 or number 16? Yes, we're on number 17 now. Oh, I'm sorry, you were answering Aiden's question. Sorry, never mind. All right, we're on number 17. So is it talking about if the base is 6 by 4 feet, the height is 2 feet, and we need to fill it with soil, and we need to know how many cubic feet that is? Are we talking about perimeter? Are we talking about area? Or are we talking about volume? It could be one of those 3. The answer for 16 is not 18. 6 times 3 is 18, that's true, but you also had to multiply by the height. You're multiplying 3 things when you find the volume: the length, the width, and the height. Area is just when we're covering something, when we're covering the surface. We're not just covering this garden bed with dirt, we're filling it full of dirt. So here we're talking about volume. So if the base volume equals length times width, a base is made up of length and width. So we can fill in our numbers, 6 by 4 feet, and the height is 2 feet. And when we find the volume of that garden bed, we'll find the amount of cubic feet of soil we need to fill that garden bed. So you're going to do 6 times 4 and that times 2 to find the cubic feet needed of dirt. I think I was going a little fast, Graydon. They're saying that 36 cubic inches is the answer to number 16. And the answer to number 17 is something different. And Karina and Callie and Brandon, you and Julia and Adam, you got number 17 correct. Actually, we should add in properly 48 cubic feet, right? Because when we're talking about cubic inches, that's volume. When we're talking about square units, that's area. And just regular plane units is perimeter or distance. All right, you guys ready for number 18? 3 more, 18, 19, 20, almost done. All right, a seamstress, somebody else who's sewing. I'm glad some other people do. I can't do it. I don't think I ever really learned properly though. A seamstress needs enough lace to trim. A seamstress needs enough lace trim to cut 24 1-foot lengths of lace. What is the number of yards of lace the seamstress needs? So she needs to cut 24 1-foot lengths. So here's 1 foot, and I need to cut 24 of these. So I'll have 24 feet altogether, right? So there's 24 feet. What is the number of yards of lace the seamstress needs? If we're dealing with 24 feet and we need to know how many yards that is, we know that there are 3 feet for every 1 yard. And if you remember, or if you notice, we're going from small units to big units. When we go from big to small, we multiply it all. When we go from small to big, we divide. You dig? There's my corny rap for the day. I think I've humiliated myself enough for you people today. All right, what do you think? So going from small unit to a big unit, we're going to take 24, divide it by 3 to get the number of yards. And you should get your answer. Absolutely, Graydon. Awesome, Adam. All right, Aiden, we'll see you later. Glad you could join us for a little while. All right, number 19. Each day, every day, a volunteer at an animal shelter feeds 36 8-ounce portions of dog food to the dogs at the shelter. How many pounds of dog food does the volunteer use each day? So it sounds like we're talking ounces and pounds, and it sounds like another conversion where you would normally get out your handy dandy reference chart. You may not have one. You have Google probably at your fingertips, but let's record our information. We have 36 8-ounce portions per day. Well, see, this is how one portion is 8 ounces, but they do 36 portions. So if I find the total number of ounces, that's 36 times 8, right? 8 times 6 is 48. 8 times 3 is 24, 25, 26, 27, 28. That's 288 ounces per day. But the question is not asking how many ounces per day. It's asking how many pounds per day. Do not give up. I know I'm going fast, Carter, but you don't have to. Stick with us. Watch the video as many times or slow it down as much as you want, okay? So we have 288 ounces. Our conversion is this. There are 16 ounces for every pound. So when we go from small to big, we divide. You dig 288 ounces divided by 16 pounds, or ounces in 1 pound will give us the number of pounds. So 16 into 28 is 1 time. 8 minus 6 is 2. 2 minus 1 is 1. Drop my 8. 128. And then you can figure out how many times 16 will fit into a 8, and you should not have a remainder. So if you can finish this division problem, you'll be able to figure out how many pounds are equal to 288 ounces. Kirby, we are on we just finished question 19. We're gonna go over 20 and then I'm gonna ask for questions. Callie or Brandon, thank you so much for encouraging our other students. That's pretty awesome of you. What's a portion? It's like a part, like a piece. So instead of we're going to go to the question answer piece, I say we're going to go to the question answer portion of the video. Okay. All right. Paulo, there's so many Friends references. It's not even funny in this homework.
I tried to keep saying this to Mrs. Whiskerson.
Huh?
I tried to say Mrs. Whiskerson if you heard.
Mrs. Whiskerson.
Yeah.
All right. Paulo's lizard weighs 50 grams in number 20. What is the weight of the lizard in kilograms? Okay. Stick with me here. Celine, you would be correct. 50 grams. Okay, I'm going to do a little, instead of moving decimal points, I'm going to try it this way. I'm going to do it with a conversion like we did our meters and millimeters and stuff because it works the same way. Grams and kilograms work the same exact way. So there are 1,000 grams for every kilogram. Okay? Grams. Well, 500 is half of 1,000. What's half of 1? Okay. What if I had 250 grams? That's half of that. Well, what's half of 5/10 or 50 hundredths? 25 hundredths. So do you see a pattern that's also linked between the equal on each side of the equal sign? So if I had 100 grams and I follow the same pattern, I should have 1/10 kilogram. All right. The lizard, going back to our question, the lizard only weighs half of this at 50 grams. So if 50 grams is half of 100 grams, what's half of 1/10 of a kilogram? Did you guys want me? Yes, Brandon, you are right. Did anybody want me to explain it the other way with moving the decimal point? It's not 1/10, Karina, because 1/10 is equal to 100 grams. And the lizard is actually 50 grams, which is half of 100 grams. So we're looking to get 1/2 of all of this. So 50 grams is going to be equal to half of 1/10 of a gram. Does anybody want me to do the thing where you move the decimal or want to hear it a different way? All right, you guys. We're done. Who's got a question for me? I'm so glad. I'm so glad it's helpful. It's kind of weird because I could never make, let's see, we've been going for a little over an hour. I could never, ever get you to sit for an hour of math problems. But you did, which is why I love doing this. The lag is real. What does that mean?
Lag.
I lost track of time. See, it's easy to do. I'm not Becca's starving, but I'm not even hungry.
What?
You're still confused on number 20. Okay, can we do number 20 again, just the other way? If you got good notes, you can copy that down. Is it straight on your computer? Can you see it as 1,000? Oh, Brandon, I'm sorry. Celine, you are correct. I hit the dab and hit the whoa last week, so which you guys should Google a video of a UCLA gymnast who hit the whoa during a Beyonce floor routine. It was awesome. All right, I'm going to erase this so I can do number 20 again, but just a different way. Okay, so the lizard weighs 50 grams. Can you put that away, Becca? Okay. I know that for every 1,000 grams, I'll get 1 kilogram. So in a sense, if you think about it, 1 gram is 1,000 times smaller than a kilogram. So to turn it into a kilogram, I need to make it 1,000, my number 50, 1,000 times smaller. And how do we do that? By changing the value itself. That's where the power of 10 comes in, and it's so beautiful because if you know the power of 10, it all works out. The invisible decimal in 50 is right here because we know after the decimal we can add as many zeros as we wanted and not change the value of 50. However, if we were to move this little guy 1 place value to the left, we're actually dividing it by a power of 10, or we're decreasing the value by a power of 10. And if we do another place value, we decrease it by another power of 10. Well, 2 powers of 10 is a power of 100. And we're trying to get 1,000 times smaller. So we have to move over. Let me make this a little bit more accurate. I'm not changing anything. I'm just. So there's 10 and there's 10. We need to go one more place value to make it by a power of 1,000 or 3 powers of 10. 10 times 10 times 10. Each time you move a place value, it's a change of a power of 10. So we don't have any digit here, so we're going to fill it in with a 0, move the decimal 3 times for a power or make it 1,000 times smaller, and that's the number we're left with. Now you don't see, well, actually, it's not multiple choice. You have to write the number in there. And you see you only have room for hundreds. Well, it says 50 thousandths, but in order to make it work for this answer, you would have to record it and recognize 50 thousandths as 5 hundredths. Does that help? A lot of stuff going on in that question just because. All right. Somebody wanted to go, what? Oh, my. We're waiting, Karina. You think you've got it? You got it? All right. I'm stuck on number 8. You had to help your dad with something. Thanks, dude. All right. Number 8. What's number 8 all about? Oh, that was our graphing question. Okay. We actually had one like this, didn't we, today or yesterday? We're going to go back over to our handy dandy graph. And here's what we did with number 8. Number 8 says the graph represents the relationship between the number of weeks, W, and the number of softball games, G, that a team played. Which number pair extends the pattern shown on the graph? So what we did is all the dots right here, we connected a straight line through them and extended the line past the first and the last dot. And then we tried each number pair. It gives you 4 choices. And when we looked at each number pair, we tried F, 5, 10. So we went over to 5 and see where we would put that dot. That's nowhere near our line, let alone fall on it. You can't see it that good. That's nowhere near our line because our line is here. Okay. 6, 15. Well, let's see if that falls on the line. 6, 15. It's close. Still not on the line, though. 15, 5. We'll go over to 15 and up to 5. Again, nowhere near. Let's try 5. Over to 5, because that always comes first, and up to 15, which would fall right on our line up there. So when it asks for which number pair or which coordinate pair extends the pattern shown on the graph, meaning the line that goes past the dots that are already given, this dot right here extends the pattern. Okay? You're so very welcome, everyone. All right, Maddie, I'll see you later. See you tomorrow, the last day before spring break. Okay, what number? Oh. Well, Kirby, I hope you feel better. Sorry you're sick. Then you don't need to be sick during a vacation. Get it done and over with now. All right, Adam, you getting going? I'll see you later. Does anybody have any other questions? All right, Julia, we'll see you later. Okay, sweetie. Bye, Kirby. Hope you feel better. Yes, please turn in homework tomorrow. I'm excited to see all these 100s. What?
What do you think?
Well, Brandon, the answer is the point that we decided that fell on the extended line. All right, guys. I think I'm going to get going. If you guys don't, Becca's hungry and won't get off my back. You know, Miss Pettyjohn, she was here last week. She just didn't want to say anything. So if you're there, Miss Pettyjohn, you can say hi. She said she got on last time for just a little while, so I don't know if she's still here or not. She just, oh, I love you too, Curbs. See you later. Llama Logan, is that Miss Pettyjohn? Is that Logan C? Is that Logan L? Somebody's messing with us. How come you're sad, Karina? All right, there's our familiar sound from the middle of the day. Oh, okay. Hi, Miss Pettyjohn. All right, guys. Any other questions? Yes, you hear it too, right, Carter? Yes, we have to deal with it. You can hear it from there, though. You're sad because tomorrow's the last day of school. Only for a week, though. And we'll be back on Monday, the 16th. All right. I'm going to go. Aunt Jenny's asking you when your birthday is.
Tomorrow.
Aw. But we'll be back soon, right? Okay. And you can always send me messages over Remind, or I guess you can message me on this thing too on YouTube or Canvas if you remember how to get in there when we come back from spring break. We'll also be doing that. I didn't get enough computers to do what I wanted to do this week, but we're going to try to make it happen after we get back from spring break and make some videos of our own. All right, sweetie. I'll see you guys later, okay? Bye.